Welcome to MaxxEcu Training Part 36. In this video, we're going to be taking a look at working with open loop style boost control. Now in open loop control, we'll find that we have a basic duty cycle that we're going to be programming in our Max that we can send out to a boost solenoid to increase the boost pressure past the wastegate spring. Now we're going to find we have all kinds of programming capabilities within the Max. We can do boost by speed, boost by gear, boost by time. We're going to be breaking down how to go and set up a boost control solenoid in the routing as far as an internal wastegate versus an external wastegate, and then go through all the basic programming in our Max so that we understand how to integrate using our basic open loop style boost control in our programming. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our open loop style boost control programming within our Max ECUs. Our open loop boost control is the most simplistic way we can deal with turning up the boost pressure on a turbocharged engine. We find that we have a wastegate that's going to be fitted to our turbo assembly, and that's going to be regulating what the boost pressure is going to be at based on the actuator or spring level in the wastegate itself. We find if we have a 10-pound wastegate spring, that's going to be the minimum boost we're going to build. If we want to go in and turn the boost up and increase it, we're able to do that using a boost control solenoid. We're going to learn how we can program a normal 3 or 4 port boost solenoid within our Max ECU here to be able to achieve higher boost pressures, again, only on a turbocharged engine. This isn't applicable on a naturally aspirated engine or on a supercharged engine. This is going to be specific to turbocharged engines. Now, before we talk about any of the programming, setup, and configuration details for open loop boost control, I want to talk about the fundamentals of what's going on with a turbocharger and a wastegate, so we understand exactly what we're doing in the programming when we're going in and doing our open loop boost control. It's very important to understand these fundamentals. A lot of people get confused with boost control, and if you have things broken down and understand mechanically what you're actually doing, it'll make a bit more sense as we're programming. So first thing I want to talk about is the function of a turbocharger. It's relatively simple. We're going to have a turbine wheel and a compressor wheel. And the compressor wheel is going to generate the amount of flow and pressure that's pushed into the engine. But in order for that compressor to spin faster and faster and generate more flow and pressure, it needs to have the turbine wheel spun faster and faster. We'll find the turbine wheel and compressor wheel are mated onto a common shaft. So if the turbine spins faster, the compressor spins faster. Now we'll have housings that are going to be containing the amount of pressure and flow on the compressor side. That's going to be funneling out that pressure and flow into the engine. And on the turbine housing side, or the turbine wheel side, we'll have a turbine housing that's going to be directing the pressure and flow from the engine into the turbine housing to spin the turbine wheel faster. The turbocharger is going to be fitted to the engine on an exhaust manifold. That's where it's going to funnel all of the exhaust gas out of the engine into the turbine housing to spin the turbine wheel faster. So when we're dealing with a turbocharger, if we want more boost and power potential out of the engine, we need to turn up our shaft speed or spin our compressor faster. That's accomplished by spinning our turbine wheel faster. So when we're talking about a turbo engine and we're talking about dealing with a certain level of boost that we want to achieve, we need to be able to regulate what the turbine wheel is going to spin at to regulate what the compressor wheel will spin at. It's not going to be uncommon for a turbocharger on the compressor to spin at least 100 to 200,000 RPM, depending on the specific turbo you're dealing with and all the details associated with that compressor. Everyone will be a little bit different, so I'm not going to cite any specific turbocharger, but that's going to be the general range of operation for most turbos, anywhere between 100 to 200,000 as we start to get into the higher boost pressures. So in order to achieve those certain shaft speeds, to achieve a certain level of power potential or certain boost potential, we need to regulate the turbine wheel, how fast it's going to be spinning. And that's where a wastegate comes into play. A wastegate is going to be on either the exhaust manifold, as we find with an external wastegate, or it's going to be mounted on the turbine housing, as we find with an internal wastegate. In either situation, we'll be bleeding off a certain amount of exhaust pressure and exhaust flow through the turbine housing to spin the turbine wheel faster or slower. It's our mechanical means of regulating what we want for power potential and boost pressure out of the turbocharger that we're working with. So let's quickly take a look and talk about our internal versus external wastegates. Essentially the same concept we have going on, but it's going to be achieving it in a slightly different mechanical manner. When we're talking about an internal wastegate, and taking a look at this particular example, we're going to find on the turbine housing we have a flapper door that can open or close. If the flapper door is fully closed, all of the pressure and flow go through the turbine housing through and spin the turbine wheel as fast as possible. That would be trying to achieve the maximum boost. If that flapper door is open all the way, that's going to be dumping the maximum amount of pressure and flow and bypassing the turbine wheel. And as a result, we should find that we have less boost and less flow and less power potential out of our engine. So we have that flapper that we can control with an internal wastegate. So the internal wastegate is going to have an actuator housing that's going to have our diaphragm and spring pressure in it. And then we're going to have a connecting rod that connects to that flapper on a specific pivot arm. And then every time we're going to get into boost, we'll find that if we apply the pressure that we're finding, our pressure reference or the boost pressure, to the nipple on the top of the actuator on the internal wastegate, that's going to have that arm move and start to open up at whatever the spring pressure is within inside of the internal wastegate assembly. If that's an 8-pound spring, mechanically it will open up and move that swing arm to open up the flapper door so that we achieve approximate to 8 psi of total boost pressure, essentially spinning the turbine wheel a fixed amount in order to achieve that boost pressure. And if we go and put a 20-pound actuator on the turbo, it'll build 20 pounds and it'll start to move that swing arm. So essentially we're allowing more flow and pressure to go through the turbine housing and spin the turbine wheel faster. So it's really going to be a basic mechanical system. Now, if we take our wastegate line, the actual line going to the nipple on the actuator, and we remove it, it'll try to go to the maximum boost. It won't want to open that pivot arm, that swing arm, it won't open it, and then we'll find all of the pressure and flow will go through the turbine wheel and spin it faster and faster. So we need to make sure as we're dealing with an internal wastegate.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.